Hi folks, today we're going to talk about chemical reaction types. On Monday and Tuesday we learned synthesis and decomposition, and today you'll be introduced to two more types of reactions that are common. Here's an image that shows a silver necklace in a before on the left and an after shot on the right. You'll see that there's quite a bit of tarnish on the left, and those are the rough areas that you see here, and they're also a little bit darker. Silver tarnish is made of a compound called silver sulfide. And I learned that by using a baking soda in boiling water solution, that silver sulfide would not necessarily be removed, but the sulfur would. And that would result in the silver remaining behind, not being polished away. And what I'd like to do is show you here and also here that the dark spots are removed and that the chain itself has become brighter. I'll show you what I did. First, I lined a pan with aluminum foil. Then I mixed 2 tablespoons of baking soda in boiling water. I added the solution and the necklace to the pan. You can see the water level right here. And I waited. What happened is we put the aluminum foil down, and the aluminum foil has essentially these atoms of aluminum that are on its surface, and that's what these blue circles are representing. Aluminum is a solid metal. It has no charge when it is like that. You know, though, however, that when it is ionized, aluminum has a 3+ charge, and I'm going to indicate that here, even though on the aluminum foil itself, these atoms are uncharged. The plus is to remind you. We added water, and in the water there was baking soda made of sodium ions and bicarbonate ions. As a dry powder in your cupboard, we don't have a charge on these things. They're a crystalline solid. But here in solution, the ions dissociate into plus and minus. Now I've added the necklace. The necklace is silver, and here I'm indicating the silver atoms that are on the surface of this solid metal. Again, these are atoms that when they become ionized will be positive, and here they are. I'm showing them in association now with sulfur ions gleaned from the environment, which is what the tarnish is made up of. And there's the plus ion and the minus. Now the sodium exerts a force on the sulfur because of the different charges and pulls it out of solution, which then is attracted to the aluminum. What you see here is quite a lot of electron activity that I am not indicating, because I've told you in the past that electrons energize everything, and that chemical reactions happen because of the transfer of electrons between and among different elements in compounds. And so that's what's happening here. And what I want you to see, though, is that the sulfur is being transferred from the silver to the aluminum, being in association with the aluminum. And that is what is going on. Now we're going to take a look at what the chemical equation actually looks like. What's happening in this reaction is that we started with silver sulfide, and then we added aluminum, and it went to silver metal plus aluminum sulfide. Notice that I have balanced the formulas so that we have aluminum 2, sulfur 3. I'll balance the equation itself by adding the coefficients. Let me check this. I have 3 times 2 silver, that's 6 silver. I have 2 aluminum. Here we have 2 aluminum, 3 sulfur, 3 sulfur. Check. We did that correctly. You can see that the sulfur has gone from being in association with the silver to being associated with the aluminum. This is because aluminum is more reactive and is higher on the activity series. This is what's known as a single displacement reaction. It follows the general formula AB plus C goes to A plus CB. And you can see that we've written the cation first, as is the norm. Once again, here is the general formula for a single displacement reaction. You can add this to the worksheet.